Howdy, and let's take a look at particle motion problems and how to solve them. All right, so let's take a look at number one here. It says at time 0, the particle starts at rest. Okay, so that's our first key, that the velocity at time 0 is 0. It's not moving along a line. So this is a one-dimensional problem in such a way that at time t, we have an acceleration function here. The acceleration at time t is 24 t squared. So that's feet per second. Through how many feet? So that's the total distance. Does the particle move during the first 2 seconds? So that would be from time 0 to time 2. All right, so what we need to play off of here is we need to come up with a velocity function. So the velocity of t is going to be the antiderivative of 24t squared dt, which works out to be 8t cubed plus some constant. Now we can get that constant because we have the initial value that at time 0 the velocity is 0. So that's at time 0 plus c. So this equation solves that c is 0. So the velocity of t at any time is 8t cubed. All right, so distance traveled is the definite integral from 0 to 2, from time 0 to time 2 of the absolute value of 8t cubed dt, but on that interval 8t cubed is always positive, so it's just the integral from 0 to 2 of 8t cubed dt. The antiderivative of 8t cubed is 2t to the 4th. From 0 to 2, 2 to the 4th is 16 times 2 is 32. 2 times 0 is 0, so that's going to be 32 feet, which I believe is answer A. All right, so that's number 1. All right, so let's look at number 2. A particle moves in a straight line with a velocity, so they give us a velocity equation. Velocity of t is t squared. How far does the particle move from t1 to t2? All right, so the distance here will be from 1 to 2 of the absolute value of t squared dt. Again, t squared is positive on the entire interval, so we can take it out of the absolute value. So let's see, this is going to give me a third t cubed from 1 to 2. 2 cubed is 8 thirds minus 1 third should give me 7 thirds, which is B. All right, so that one wasn't so bad. So number 3 says they have an acceleration of the body moving in a straight line in terms of t. So the acceleration, all right, so we fixed that. Let's try this again. The acceleration at time t is 8 minus 6t. Okay, so that's our acceleration. We know that the velocity at time 1 is 25. So we want the distance of the body, so the distance from the body from the origin is s of t. So we want s of 4 minus s of 2. Okay, so we basically want the displacement from time 2 to time 4 here. All right, so let's find v of t. V of t is the antiderivative of 8 minus 6t dt, which becomes 8t minus 3t squared plus some constant. And that constant can be determined by the initial value. So we're 25 when t is 1. Okay, so we're 25. Let's see, that's 8 minus 3 plus c. 25 is 5 plus c, which means c is 20. So we now have the velocity equation. The velocity equation is 8t minus 3t squared plus 20. Okay, so s of 4 minus s of 2 should be the integral from 2 to 4 of the velocity equation 8t minus 3t squared plus 20 dt. Right, so that's going to be 4t squared minus t cubed, right, plus 20t from 2 to 4. So if I load the 4 in there, let's see, 4 squared is 16 times 4 is 64. 4 cubed is 64 plus 20 times 4 is 80. And then we're going to subtract from that. Let's see, 2 squared is 4 times 4 is 16. 2 cubed is 8 plus 40. So this is going to be 80 because the 64s fall out. That's 8 plus 40 is 48, so it's 80 minus, right? So that should be a minus 48. What's that give me? 232, right? So that's 32. So the answer to that one is D. All right, so let's look at number 4 here. 4 says I have a point moving in a straight line so that the distance from time t is a fixed point on the line. All right, the distance at time t. So my position, right, my s of t is 8t minus 3t squared, right? I want the total distance from t1 to t2. All right, so I need the velocity function here. The velocity function is going to be 8 minus 6t. So my total distance will be the integral from 1 to 2 of 8 minus 6t dt. And that should be absolute value. And that's going to make a difference here, because this thing is not always positive. If I have 8 minus 6t, when is this positive? When is this greater than 0? Negative 6t is greater than negative 8. T is less than 4/3. So this becomes something I have to split up. Okay, 1 to 4/3, I'm 8 minus 6t dt. And then from 4/3 to 2, I'm 6t minus 8 dt, because I have to change the sign because of the absolute value there. All right. Okay, so let's take a look at this. We are 8 minus 6 times... Oh, sorry. Let's try to take an antiderivative there. All right, so this is 8t minus 3t squared, which is what we knew, 1 to 4/3, plus, now this one is going to be 3t squared minus 8t from 4/3 to 2. All right, so 8 times 4/3 becomes 32 over 3 minus 3 times 4/3 squared. Let's see, that's going to be 3 times 16 over 9, which is negative 16 over 3. All right, so that's going to be minus 8 minus 3 plus, let's see, 3 times 4 is 12 minus 16 minus, and then we get 16 over 3 minus 32 over 3, right? So if we bunch up all the fractions here, let's see, this is 32, 64 minus 32 over 3 is 32 over 3 minus 5 minus 4. So let's see, 32 over 3 is 10 and 2/3 minus 9 is 1 and 2/3, which is 3, 4, 5 thirds. All right, so that's my answer, 5 thirds. So let's go with sorry, I lost the problem. Answer C. There we go. Okay, so let's look at number 5 here. A particle moves on a curve, so we have a way to get between x and y. And we know that y is the natural log of x. Okay, great. We know that x prime of t, that's my velocity, in the x direction is t plus 1. Okay. And we know that x of 1 is 1 and x of 0 is 1, y of 0 is 1. Okay. So we have okay, so we can find x of t. So let's take the antiderivative of x prime of t. dt should be x of t, right? So this should give me the antiderivative of t plus 1 dt should be 1/2 t squared plus t plus c. But x of 0 is 1, so 1 should equal 1/2 times 0 squared plus 0 plus c, which means c is 1, which means x of t is 1/2 t squared plus t plus c. Okay, so x of one then would be 1/2 times 1 squared plus 1 plus c, right? So this, oh, sorry, plus this c should be 1. We just figured that out, plus 1, right? So this should work out to be 5/2. So that's the x value. Well, y of 1 should be the natural log of x at 1, so it should be the natural log of 5/2, which works out to be letter C. All right, so let's look at number 6 here. Problem number 6 says the velocity of a particle moving on a line at time t is given by velocity is 3t to the 1/2 plus 5t to the 3/2. Okay. And we want to know distance traveled from 0 to 4. So this is going to be, the distance is going to be the integral from 0 to 4 of the absolute value of 3t to the 1/2 plus 5t to the 3/2 dt. On that entire interval, this is always positive, so this is just that. We can get rid of the absolute value. Okay, so when I take the antiderivative here, the antiderivative of this is going to be 2t to the 3/2. The antiderivative here will be 2t to the 5/2, and that's from 0 to 4. Let's say it's going to be 2 times the square root of 4 is 2 cubed is 8, plus 2 times the square root of 4 is 2 to the 5th is 32. This is going to be 2 times 0 plus 2 times 0, which works out to be 16 plus 64, which is 80. And that is answer D. There we go. Let's look at problem 7. In problem 7, we're told that the velocity at time t is 2t minus 4. So the position at time t should be the antiderivative of the velocity at time t, which should be t squared minus 4t plus some constant. But we're also told that the position is 4 when t is 0. So that means that ultimately c should be 4. So x of t works out to be t squared minus 4t plus 4, which is answer C. All right, so I think I did that a little bit quicker than I did in the sample answers online, but you see 2 methods for doing it. Okay, so number 8, we get a velocity function, v of t is equal to e to the t. We want to know the distance the particle moves from 0 to 2. So distance should be the integral from 0 to 2 of the absolute value of e to the t dt. Again, e to the t is always positive, so that's going to be that way. The antiderivative of e to the t is e to the t from 0 to 2. So this is e squared minus e to the 0, which would be e squared minus 1. So that guy is A. Okay, so let's look at problem number 9. A particle travels in a straight line with a constant acceleration of 3. So A of t is equal to 3 for all t. The velocity, so we get an initial value for the velocity time 2. The velocity is 10. We need to know how far does the particle travel from when the velocity increases from 4 to 10. All right, so velocity at time t is equal to the antiderivative of 3 dt, which is 3t plus some constant. But at time 2, the velocity is 10. So c, 6 plus c is 10. C has to be 4. The velocity at time t is equal to 3t plus 4. So the velocity is equal to 4 when t is 0. So we want the distance from time 0, right, which is when the velocity is 4, to time 2, which is when the velocity is 10, of the absolute value of the velocity. So this should be, that's always positive on this interval. So we can just play that game. That's going to give me 3/2 t squared plus 4t, right, from 0 to 2. If I put 2's in there, I get 3/2 times, wait a minute, 3/2 times 4 is going to be 12/2, so it's going to be 6 plus 8 minus 0 plus 0 is 14. So it's 14 meters. The answer there is B. All right, so the last one here is problem number 10, right? 10 tells me the velocity of the particle moving along the x-axis at time t. So we have the velocity. Oops. Whoa. All right, we get an acceleration function, right? So the acceleration is 6t minus 2. The velocity at time 3 is 25. And the position at time 1 is 10. We would need to know the position function in general. So velocity of t is the antiderivative of the acceleration, which is going to give me 3t squared minus 2t plus some constant. The velocity at time 3 is 25. So let's see, that's 27 minus 6 plus some constant. 25 is 21 plus some constant, which means the constant is 4. So the velocity equation is 3t squared minus 2t plus 4. Okay, so the position equation is going to be antiderivative of the velocity equation. So that's going to be t cubed minus t squared plus 4t plus some second constant. But we know the position is 10 when time is 1. Let's see, 1 minus 1 is 0, so this is going to be 4 plus that second constant, which means the second constant is 6. So the position equation should be t cubed minus t squared plus 4t plus 6, which looks a lot like C. All right, there you have it. Stay safe, stay healthy. If you've got more questions on this, come to the drop-in session, the next one that we have. Bring them with you, and we'll see how things go. All right. Hope you're all well. Thanks.